Hello, Bobcats. Again, Mrs. Wilhite. We're in 5th grade math. We're still in chapter 1. We're moving on to our third lesson in chapter 1. We can see still in place value. We can also notice it is a 5th grade standard again, something you need to learn for all the math that's coming your way. And our objective today, or what I'm hoping, is you'll be able to, use models to relate decimals to fractions. Okay, so something that stands out to me right away is that word relate. When you relate two things, you find how they're similar, you find what they share. Also, I noticed that word decimals and the word fractions. So today we're going to be relating decimals and fractions. And when we look at our objective, it goes right into what's the purpose? Why, Mrs. Wilhite, do I need to learn this? What is the main idea? How is this going to help me? Well, of course, it's school. You have to do your schoolwork. It helps you with your grades and your educational career. But beyond the school career, it also helps you see that things can and are equivalent. When you think about 25 cents, my daughter's 4 years old. If I give her a quarter or I have a pile of 25 pennies, she's going to grab those 25 pennies and she's going to think she's all the richer. And I was just silly to even try to offer her a quarter because clearly these 25 golden tickets here or 25 golden coins is worth so much more. But we, being older in our experience, know that the two values, 25 cents and 25 quarters, are equivalent. And so in today's lesson, I want to show you or relate the values of decimals and fractions and how they can be equivalent or the same. Also, when you're cooking, those of you that will be chefs or those of you that just want to feed your family or feed yourself, you have to be able to work with values, the amount, or something that is less than 1. Because when we think about decimals and fractions, we're talking about values that don't quite equal that whole number, right? It's less than 1. So today, hopefully, our objective will be that you'll be able to relate and use models, those visual models, fractions and decimals, that they can be equivalent, and we're going to show that with our visual models. Since we'll be dealing with decimals and fractions, I want you to think about, what do you already know about decimals? Well, when I think about decimals, I think that they have digits in the tenths place, hundredths place, and of course beyond. Those are the decimals, values less than 1. And it says a decimal point is used to separate the ones place from the tenths place. So if I have $1, I can put this decimal to separate, to have a barrier between that one, that whole value, and what's after the whole value. So if I put a 2 after that decimal, then that's the tenths place. It has a value less than 1. It's actually 2 dimes or 20 cents. If I put a 1, then that's the hundredths place. Anything that's on the right side of the decimal is going to have a value of less than 1, and these are the decimals. So from my experience, I know that a decimal can really act as a barrier. This decimal can separate whole numbers and values that are less than 1. And now that we've been reminded about how fractions and decimals are relating and that they also show values less than 1 and the decimal is separating, we can get into the steps to solving the problems today. Well, step 1, it says shade a model to represent the value. So we're going to shade a model. Yay, we get to actually do some visual drawing. Okay, and after we shade that model, we're going to either create a fraction or a decimal. Some problems we'll have to make the fraction, and others it'll be the decimal. But remember, fractions and decimals can be equivalent in their worth or their amount or their value. So shade that model, make that visual, create a fraction or a decimal, and finally, is it reasonable? Does it make sense? Can I really move on? Do I know that I have the right answer? All right, Bobcats, example 1. Use a model to show 3/10 or 3 out of 10. Then write it in word form and as a decimal. Well, step 1 we just talked about is shade the model. So I'm going to go ahead and shade 3 parts out of 10. So 1, 2, 3. Now that I've shaded 3/10, I can move on to step 2, which is writing that decimal or fraction. Well, it's asking me here to use a decimal and to write it in word form. Well, from lesson 1, we know that word form only uses words. We can't have any digits. So I would write 3/10. 3 out of the 10 total in the model. And then if I'm going to write it as a decimal, I'm going to put a 3 in the tenths place because I have shaded 3/10. Finally, is it reasonable? Well, it's reasonable because I know tenths is a decimal, so it's going to be on the right side of the decimal or of the barrier, the separator. So the 3 is in the tenths place. It's reasonable. All right, example number 2, it says use a model to show 9/100ths. Because the 9 is over 100, it's hundredths. Then write it in word form and as a decimal. Well, step 1, we're going to shade the model. I need to shade 9 out of 10. Right here, 9. Now, if I look at the bigger picture, I shaded 9 out of 100, which is what the fraction says, 9/100ths. Once I have shaded my model, I can move into step 2, which is write it as a decimal or a fraction. Well, it says write it as a decimal and use that word form. Well, I can write 9/100ths. I need to make sure that in my word form, I do not have any digits. And I have 9 on the top of the fraction. And the bottom of the fraction tells me to write hundredths. I'm going to write the word hundred and then add that THS, 9/100ths, showing that it's a value that's a decimal, less than 1. After word form, let's put that decimal. Well, I can't put it in the tenths place, so I better put a 0 to hold that tenths place. I'm going to put the 9 in the hundredths place. So I have 9/100ths, or 9 over 100, as in the problem itself. I have written it as a decimal, which is 9/100ths, with my barrier showing that it's a value less than 1. And then finally, I have my word form. I know it's reasonable because 9/100ths is the same value in all 3. It's all written very differently, but they have the same worth, the same amount. They are equivalent. Again, 2 nickels equals 10 cents. A dime on the table is going to look very different than 2 nickels or 10 pennies, but all 3 values are equivalent, just like 9/100ths. 9/100ths as a model, 9/100ths as a decimal, 9/100ths as a fraction, or 9/100ths in word form. All look very different, but again, they are the same value. Example 3, use a model to show 34/100ths, then write it in word form and as a decimal. Well, I'm going to shade 30, 10, 20, 30, and then 4 more. So 34 out of 100. So I shaded 34 of the small squares. I can write it in word form, which of course I'm not going to have those digits. And then after I write that 34/100ths, then I can go ahead and write it as a decimal. Again, reminding you that even though they all look very different, the word form, the model, the fraction, the decimal, they are equivalent. They are all the same value. I'm going to put my decimal, showing that it's less than 1, making sure I write my number on the right side of the decimal because that's where we have values less than 1. 3 dimes, 3/10ths, or 30/10ths, 34/100ths. I established the answer in word form as 34/100ths. I know it's reasonable because if we look up here, the fraction 34/100ths, the model 34/100ths, the word form 34/100ths, and the decimal 34/100ths are all equivalent. They have the same value. It's reasonable. All right, this one looks a little bit different. We're not dealing with tenths. We're not dealing with hundredths. There's definitely a lot more cubes. It says the model at the right shows a thousandths cube, so there must be 1,000 of those little boxes. What fraction of the model is shaded? Oh, I see a question mark, and you know I like to underline any question with that question mark. Write it as a decimal. Well, let's look at the question. What fraction of the model is shaded? Well, I theorize the fraction is, well, I'm going to put my fraction line. We know there's 1,000 total cubes, so that's my bottom value. How many out of 1,000? Well, there's 4 shaded, 4 thousandths. I surmise the decimal to be, well, I need to put a 4 in the thousandths place. Well, I'm going to put my barrier, my decimal, because it's less than 1. It's not 4 tenths, and it's not 4 hundredths. It's 4 in the thousandths place. So I can go ahead and put 2 zeros to represent 0 tenths, 0 hundredths, and put 4 in the thousandths place. This is reasonable because, well, if I look, 4 out of 1,000 has the same value as 4 thousandths and 4 thousandths. They're all equivalent. They're written differently, but they have the same value. It's reasonable that my answer is correct. All right, shade the model to show 80 hundredths. Then write the fraction in word form and as a decimal. I'm going to use those steps to help me. Well, step 1 says shade the model, so I'm going to go ahead and shade 80 out of 100, or 80 hundredths. So if I look at this 80, I know that I have to shade 10, 20, 30, 40, 50, 60, 70, 80. 80 total squares out of 100. Now that I've shaded the model, step 2 is to write it as a decimal or a fraction. Well, it's telling me to write it as a decimal. Can we write it in word form? Of course we can. We just write it so that we don't have any digits and we have only words, so 80 hundredths. And I'm going to make sure to put that THS in my spelling because that helps you realize it's less than 1 on the other side of that decimal, the barrier. I concluded the decimal to be 80 in the hundredths place. I need to make sure that last digit ends in the hundredths place. It's reasonable because the fraction 80 over 100, or 80 hundredths, and the decimal 80 hundredths, 8 in the tenths, and 0 in the hundredths, 80 hundredths, and our word form 80 hundredths are all equivalent. They have the same value. Shade the model to show each fraction. Write each fraction in word form. Well, 7 tenths. Right away I notice that there's 10 in the whole figure, so I'm going to go ahead 5, 6, and shade 7 out of 10. So I surmise the answer to be 7 is the number on top of the fraction. We start with that. And then we have tenths. I'm going to write the place value 10 and then add that THS. Less than 1. It's reasonable because 7 tenths and 7 tenths are the same amount. Shade the model to show each fraction. Write each fraction in word form. Again, I can see the model has changed on problem number 7. We now have 100 cubes. We're in the hundredths place. It's less than tenths or smaller. Right? We have 5 of the tiny, tiny squares. 1, 2, 3, 4, 5. 5 hundredths is much smaller than 5 tenths. Those 5 tiny squares are smaller. But I established the answer to be 5 is above that fraction line, so I'm going to write that as my word form. 5 and then 100, just like we normally would write. We have to add that sneaky little THS, proving that it's less than 1, or on the other side of the decimal. So it's reasonable to say that 5 hundredths and 5 hundredths are the same value as 5 hundredths. They're all the same. They look different, but again, they are equivalent. All right, we're still in practice it. We're on problem 10 now. It says write the decimal for each model. So this is different. The model is done for you. Step 1 is done. Shade the model. Well, they did that. We now have to tell the decimal. Well, I can see that there's 2 shaded in the model. 2 out of 10. I can write that as a decimal as a 2 in the tens place. Here's my barrier, my decimal. It's going to be on this side, and the 2 is in the tens place. All 3 of these are equivalent, 2 tenths, 2 tenths, and 2 tenths. So I know my answer is reasonable. So again, write the decimal for each model. They did the step 1, they shaded the model, and I can see that they have actually shaded 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 10, or 8 in the tens place. This is reasonable because there is 8 shaded out of 10. 8 tenths. Number 14, write the decimal for each model. So they're asking for a decimal. I have to look, and I can see we're not dealing with tenths. We have 100 of those tiny little squares or cubes. So I can go ahead and think about my fraction being in the hundredths place. I got to figure out how many did they shade in the model out of 100. So if I look and each of the columns is worth 10, I can see that they shaded 10, 20, 30, 40, 50, 60, 70, 80 out of 100, and then a little more than 80. Well, if I count, there's 9 here. So I have 89 out of 100 total that are shaded. But they're not asking me for the fraction. They're asking for a decimal. So I can write 89 hundredths as a decimal. Here's my decimal, my barrier, the separator. My decimals go on this side, the values that are less than 1, and I can write 89 in the hundredths place, that 9 in the hundredths place. It's reasonable because there's 89 out of 100 shaded in the model that was given. Okay, now we're moving on to apply it, word problems. Jessica's family ate 6/10 of a cake she baked. Write the amount eaten as a fraction and as a decimal. Remember, our objective is to use fractions and decimals and relate them and see how they're equivalent. I explained that you'll use this in real life with cooking. Well, here it is, 6/10 of a cake, less than 1 whole. We have to deal with values that are less than 1 whole. Can we write it as a fraction and a decimal? Of course we can. It tells us here that there's tenths. Well, I know there's a 10 on the bottom because it says tenths. And there's 6 out of 10, 6/10 of the cake she baked. My decimal is my separator from the whole numbers. The value is less than 1 on the right side, so 6/10. It's reasonable because both 6/10 as a fraction and as a decimal is less than 1. And I can see that Jessica's family had less than the whole cake. They had 6 parts out of 1, 6/10 of the cake. All right, we're going to apply it still. It's 19. Write the decimal and a fraction for each model. Are the 2 models equal? Right away, I can see a question mark. So I got to underline. Are they equal? Well, I can't tell if they're equal unless I tell the value, and I need to write it as a decimal and a fraction. Well, there's 4 out of 10 that are shaded here. So I can go ahead and write 4 out of 10. Okay, and then I can write it as a decimal, an equivalent value, the same worth, 4/10. Well, here I have 40 out of 100. Okay, so my fraction is 40 hundredths. I can write it as an equivalent value as a decimal, 40 hundredths. Well, I finished the first part. Now I have to answer the question, are the 2 models equal? Well, if I just step back and I look at this model and this model, the amount that's shaded in orange is the same. And if you look at your values, you have 4/10 or 40 hundredths. Well, really, what is the value of 0? Nothing. So if you were to not even see that 0 or understand that it really equals 0, you have 4 in the tens place, just like you have 4 in the tens place on this side. So I surmise the answer is the two models are equivalent. They are the same value. And just because they don't look the same as a fraction and they don't look the exact same as a decimal, we know that things can look different and still be the same. It's reasonable because they both have the same amount shaded in the drawing. All right, Bobcats, it's that time again. What did you learn today? Think, stop. Don't go right into that independent practice. In summary, today I learned that fractions and decimals can be the same value. They look different when they're written, but they can be the same amount. Again, if something is equivalent or equal to something else, it doesn't always have to look exactly the same. It could be worth the same amount. It could be the same amount, but have a different appearance. All right, thank you for your time.